Welcome back. We are going to finish up our logarithm and exponential functions unit with solving exponential and log equations using logarithms. Just like when we were talking about common bases, where we said if we had 3 to the x is equal to 3 to the fourth, if our bases are the same, we can set the exponents equal to each other, and we get x is equal to 4. The same thing happens with logarithms. If I can have log base a equals log base a, then x has to equal y. Because we talked about like bases before, we always check to see, can I do like bases? In example 1, we have 7 and 12. There's no way for me to get those to be like bases. This is why we learn logarithms. We can rewrite in log form and then try to solve that way. So since I can't get like bases, if I rewrite this exponential in log form, we start with log. Remember, left, right, center. So log base 7 of 12 is equal to x. Well, x is alone, so I just need to figure out log base 7 of 12. Remember, we learned change of base formula in the last section, so that would be log 12 divided by log 7. Take that to the thousandth place, 1.277 is equal to x. 8 to the x power equals 21. Again, there's no way for me to get like bases. Left, right, center, rewriting that in log form. Change colors here. We have log base 8 of 21 is equal to x. Again, x is alone, so I just have to figure out what log base 8 of 21 is. I can use change of base formula. Log of 21 divided by log of 8. Again, it says to the thousandth place. So that would be 1.464. Base E exponential equations. Remember that natural logs go with base E. So we would rewrite using ln for natural log. For example A, we start with the natural log, left, right, center. We have base E of 200 is equal to x squared. We find the natural log of 200, and to get this x alone, the opposite of a square is a square root. So my final answer would be typing in the square root of the natural log of 200. Remember, natural log button is already base E, so we don't have to do this change of base formula. We can just hit the ln button of 200. And it again says thousandth, so we took a square root. We can have two possible answers. That's plus or minus 2.302 is equal to x. Example B. Now I can't do anything here until I get these two e's condensed into one. Well, exponent rules, when we're multiplying like bases, we add exponents. If I add like terms, 2x plus negative 4x is negative 2x plus 1. And we have is equal to 3e. If I rewrite into log form, we have natural log. Left is base e, right is 3e equals negative 2x plus 1. I would take the natural log of 3 times e. Remember, that'll be e to the first when you type that in your calculator. And that is roughly 2.099. Again, we're talking about this thousandths place. To finish getting x alone, we would subtract 1. That's 1.099 is equal to negative 2x. The opposite of multiplying by negative 2 is dividing by negative 2 on both sides. And we get x is about negative 0.549. Example C. Rewriting this into natural log form, we have natural log base e of 50 is equal to x. Remember, again, natural log is already base e, so we don't really need to worry about that e. We can just type ln 50 into our calculator, and to the thousandths place, that's roughly about 3.912. Example D, we again want to get our two bases on the left to a single base. If we're multiplying like bases, we add exponents. That gives us e. 4x plus 1x is 5x. Minus 1 is equal to 5e. Rewriting into natural log form, we have base e of 5e is equal to 5x minus 1. This is e to the first there. And again, we don't need this base e down here. Natural log is already base e. I'd type natural log of 5e to the first power in my calculator. Taking it again to the thousandths place is 2.609. To finish solving for x, we would add 1 to both sides. And then the opposite of multiplying x by 5 is dividing x by 5. And that would give us roughly about 0.722. One method for solving log equations is to rewrite in exponential form. So if only one log or natural log, rewrite in exponential form. Before I can do anything with solving, the only thing that can be over on the side with the logarithms is the logarithm itself. Right now I have a 7 there. So I have to divide by 7 because this is 7 times the natural log of x to get the natural log of x alone. Remember, natural log is base e. So I'm going to go ahead and fill that in to help me rewrite it. Base e to the 4th power is equal to x. And it says give exact values. Since e to the 4th is going to be a decimal, if I did that decimal, it would be roughly about 54.598. We would have to leave that as e to the 4th power. B. That x cubed minus 19 is grouped together. It's not separate from the log, so we don't have any isolating to do for the log itself. We can go ahead and rewrite this in exponential form. We have 2 to the 3rd power is equal to x to the 3rd minus 19. 2 to the 3rd power is 8. To get x alone, I would start with adding 19 to both sides. That's 27. And then the opposite of a 3rd power is a 3rd root, or the 1/3 power, whichever you connect with easier. And 27 to the 1/3 power is 3. X is equal to 3. Letter C, oops, that's the same color. We don't want that. We again need to get this natural log alone. Right now it's being multiplied by 4. The opposite is dividing by 4. So we get the natural log of x is equal to 9. Remember, natural log is base e. So I'm going to fill that in. E to the 9th is equal to x. If I did e to the 9th in the calculator, I would get roughly about 8103.08. But because it asked for exact values, we're leaving that as e to the 9th. For letter D, we have log base 3 of x cubed minus 5. That x cubed minus 5 is all grouped with the log, so we don't need to do anything for the log to be alone. Rewriting this in exponential form, we have 3 to the first is equal to x cubed minus 5. 3 to the first is 3. To get x alone, I would start by adding 5 to both sides. We have 8 is equal to x cubed. And then the third root of 8, or 8 to the 1/3 power, is 2. And so x is equal to 2. Now we have more than one log. So the first thing I need to do is use log properties. We want to use log properties. So let's see, I'm going to write this in here. Use log properties to condense them. We want one log on the left and one log on the right. In order to get one log on the left, we're breaking this out. Remember that subtraction started as division. So on this left side, I really have x plus 6 divided by x plus 2. And that equals log of x. Now that these are both log base 10x, log base 10x, we can say, just like bases, we set the exponents equal to each other if we have like logs, and we set the stuff on the right side equal to each other. X plus 6 over x plus 2 is equal to x. To start solving this, I need to move this x plus 2 out from underneath. So multiply both sides by x plus 2. These reduce out. We have x plus 6 is equal to, distribute, x squared plus 2x. With the x squared, I'm pretty positive I'm going to have to end up factoring. So I want to move all of my like terms together and put everything on one side. The opposite of positive x is subtracting x, and the opposite of a positive 6 is subtracting 6. That gives us 0 on the left side, x squared, plus x minus 6 on the right. We need to factor. So the factors of negative 6 that add to positive 1 are going to be positive 3 and negative 2. We solve for x by setting each of those equal to 0. We get x is equal to negative 3 and x is equal to positive 2. Well, remember we talked about how if I tried to take the log of a negative number in my calculator, I get an error non-real answer. And especially when we're factoring, we need to check for extraneous solutions. Remember, extraneous solutions are solutions that we know we did the right math for. However, when we plug it back into the equation that we started with, for whatever reason, it doesn't work in that equation. So there's nothing that we did wrong. It's just something that can't work. And so we want to take these two equations and plug them into our original problem to make sure we're not taking the log of a negative number. So if I do that, we have log of negative 3 plus 6 minus log of negative 3 plus 2 equals log of negative 3. Well, negative 3 plus 6 is 3. Negative 3 plus 2 is negative 1. And so here's a log of a negative, and here's a log of a negative. That means we cannot use the negative 3. That is extraneous. We also need to check the 2. So log of 2 plus 6 minus log of 2 plus 2 equals the log of 2. 2 plus 6 is positive 8. 2 plus 2 is positive 4. And this is a positive value, so 2 is good. That means that 2 is my only possible answer for this problem. The negative 3 is extraneous. Let's try the second one. For the second one, we again want to condense this so that we have a log equals a log. Addition started as multiplication. So this is log of 2x plus 1 times x equals log of x plus 8. Because this is log base 10 equals log base 10, I'm allowed to set just the stuff after the log equal to each other. I have to distribute my x over on the left. 2x squared plus x is equal to x plus 8. With the x squared, I know I'm probably going to have to factor. So I'm going to combine my like terms over to the left this time. Subtract x, subtract 8. That gives us 2x squared. The x's add to 0 minus 8 is equal to 0. Solve for x. I'm going to add 8 to the other side. The opposite of multiplying by 2 is dividing by 2. So we have x squared is equal to 4. Take the square root of both sides to get x alone. We have x is equal to 2 and negative 2. We have to make sure that we double check by plugging in our 2 and our negative 2 to our original problem for extraneous solutions. So log of 2 times 2 plus 1 plus log of 2 equals log of 2 plus 8. This is a positive 5, a positive 2, and a positive 10. So the positive 2 is good to go. Going with the negative 2, we have log of 2 times negative 2 plus 1 plus log of negative 2. So log of negative 2 plus 8. This is a positive 6, but that's a negative 2. There's nothing that happens to it. So that stays the same. And negative 2 times 2 is negative 4 plus 1 is negative 3. So those two right there tell me that the negative 2 is extraneous. And my only answer is x is equal to positive 2. So again, the reason for all of this is that our original domain on those graphs for logs, our domain went from 0 to infinity. You can only have positive values that you're taking the log of. That's why we need to make sure we check our solution so that we're only taking the log of positive numbers in the original equations. The log of a negative number is not possible. Making those values extraneous. Example 7, we are back to a single log. If all I have is one log, then we rewrite in exponential form. If we only have a single log, we rewrite it in exponential form. I know we've got a lot going on there, but that's okay. So I start with, I have single log, my base is 2. We have 2, let me pick a better color here. 2 to the third power is equal to 3x minus 7 times x minus 4. I'm going to FOIL, distribute, however you love to multiply on the right. It's negative 12x, negative 7x. So we have 3x squared minus 19x plus 28. And on the left side, 2 to the third is 8. I'm going to bring that 8 over. So we need to factor. 3 times 20 is 60. The factors of positive 60 that add to negative 19 are going to be negative 15 and negative 4. When I factor that, I end up with 0 is equal to 3x minus 4 times x minus 5. Because it's equal to 0, we set each part equal to 0. Solve for x. X here is 4/3. X here is positive 5. We still need to check that these are going to be valid solutions. And so, plugging in the 4/3, we have 3 times 4/3 minus 7. Oops. And that times 4/3 minus 4. Well, 3 times 4/3 is 4 minus 7, which is negative 3. But we're okay. We have to multiply that by 4/3 minus 4, which is 4 minus 12, negative 8/3. And a negative times a negative is a positive. So this is okay. And then log base 2 of 3 times 5 minus 7 times 5 minus 4. 15 minus 7 is 8. 5 minus 4 is positive 1. 8 times 1 is positive. And so both of those are okay answers for us to have. The second one, Again, we have a single log, so we're rewriting it in exponential form. 3 to the third power is equal to 4x plus 1 times x plus 1. We've got a FOIL, distribute, however you love multiplying on the right. 3 to the third is 27. We have 4x squared plus 5x plus 1. We will subtract the 27 over 0 is equal to 4x squared plus 5x minus 26. I have no common factor to reduce, so 4 times negative 26 is negative 104. The factors of negative 104 that add to positive 5 are going to be 13 and negative 8. If I write that in factored form, we have 0 is equal to 4x plus 13 and x minus 2. 4x plus 13 is equal to 0. X minus 2 is equal to 0. So x is equal to negative 13 fourths, and x is equal to positive 2. Check your work and make sure that none of these are extraneous, and both of those are good answers. Our last part, filling in these just summations here. We can try to solve by like basis if it's in exponential form, or rewrite into log form. Use change of base. If we have a single log, then we can solve by rewriting into exponential form, making sure that you check your solutions. If we can condense it so we have a log equals a log, then we know that whatever's after the log on the left side has to equal whatever's after the log on the right side. If we have an exponential function where we have two bases that are multiplied by each other, we use exponent rules to add them, and then we will rewrite into log form because this will be number 1. And then we need to check that the proposed solution is in the domain of the log, meaning are they extraneous? Because the log of a negative value is undefined or imaginary. That's it for this unit. Thanks again for joining me on exponential and logarithmic functions. Hope you enjoy the rest of your day.